really hard stuff today, okay? We'll talk about it later. Okay, today we're going to be talking about 10.6, which is type 2 errors. Up to now, we've 10.2 probability of type 2 errors.
10.6, right?
10.6. I'm going to be referring back to 10.2 because, you know, it's been a while. You guys have probably forgotten it already. Okay? So let's review really quickly a type 2 error is the probability that we do not reject the null, given that the alternative x of 1 is true. Okay? So the problem is, note, you need a specific value for your type 2 error. Okay, now, what I'd like to do, I do want to review one of the problems because it's been a while since we talked about proportions and we've probably already forgotten them, right? Okay, so I want to bring back a proportion example here. So in 10.2, we tested that p equals 0.5 versus our alternative hypothesis, which was that p was less than 0.5. Remember, we were trying to test if less than half of students were prepared. Okay? We used an alpha equal to 0.05, and we also had an n equal to 500 students. Okay? All right. So I'm just gonna I'm gonna pull that up just kind of as a thing here. Okay? So in order to find the type 2 error, steps to find the type 2 error. Okay, you're going to need to do 3 things. Okay? Find the value that leads to reject the null hypothesis. Okay? And it could be left-tailed or right-tailed, or it could be two-tailed. Okay? Step number 2, you've really got to draw a normal curve. I really don't see how you can do this without drawing a normal curve. You're going to get confused if you don't. Okay? I know some of you are still resisting that. Number 3 is to find p-value. However, it's based back on step number 1. Okay? If you're doing a left-tailed test, you want to find the value on the right. If you're doing a right-tailed test, you want to find the value on the left. And if you're doing a two-tailed value, you want to find the value in between. Okay? All right, so let's go back to our example from 10.2. I'm pulling that one up just because we haven't talked about proportions for a while. Okay, so I'm going to draw, actually, I probably should put, you know me, I always like to draw a normal curve first. Okay? All right, so based on this null and alternative hypothesis, what should be the mean? What? 0.5. So our P is 0.5, right?
Mm-hmm.
What kind of a test is this? This is a left-tailed test, we know from our alternative hypothesis. Okay? my alpha equals 0.05, what I want to do is I want to figure out where is my decision point? Where's my critical value? At what value do I decide to reject or to not reject? Okay? How do I find that value? I want to find this value here. Table, yeah, kind of. What do you mean by that?
1 minus.
Can I use your alpha? Sorry.
You're on the right track. Not quite go. I think you're a step ahead of me actually though. How do I find this value?
1 minus.
1 minus. Don't you have to find the 0.05 at the initial?
Yeah, that's what Chris said.
Oh, that's what I'm saying.
And then, what am I going to do with that value?
Define as what number.
Okay, well here, since you guys are going there, let's do that. Hopefully that'll lead you to where I'm trying to go. Okay, so you're saying look at the chart. That's probably all the information I need. Okay, what are we looking at? What am I going to find? With an alpha of 0.05, what am I finding? Left-tailed test.
Level of significance, 0.05.
Level of significance 0.05, left-tailed test, I get negative 1.645. Okay, so what do I do with that number? I got a negative 1.645. What do I do with that number?
Symmetric, so on the other, it's gonna be 1.645 on the other side.
That's assuming my mean is 0, right?
Yeah.
Okay, so I need to convert it back. So this is my standard normal. I need to convert it back to my regular normal. So I can find out what this value is.
Do you have to subtract?
How do I do that?
By 1?
Subtract it from 1. So you want me to subtract 1 from that?
No. You have to find the left. You say your z-score equals.
Z-score, that's what I was going for. So I need my z-score. What's my z equation? Or which z equation should I use, I guess is the better question.
P hat.
It's p hat
Minus.
minus p over square root of pq over n. Now I'm using this one because we've been doing a lot with the t and the z lately, right? Could you do this again if if this was a t or a z? Could you pick the right equation?
Yeah.
No? Hopefully you can do that by the test, okay? I'm using this one because we haven't done proportion for a week. Yes?
Like, use T if you don't have the population standard.
Correction. Correct. Yes, if you don't have the population standard deviation, you use T. If you do, you use Z, but it's a different form of Z, right?
Different what?
It's a different form. It's going to be x bar minus mu over sigma over square root, right? Okay. All right. Conceptually, they're the same. All right. Okay. So now I need to find this value. What do I do? Okay. Cassidy, can I take it away?
Negative 1.645 equals.
Okay, so instead of calling this p hat, I'm going to call this p critical, right? Or p reject. I don't know. What do you want to call that? It's this value here. It's your reject. Here, I'm going to call it p reject. P reject. It's your rejection decision, right? Okay. So that is,
Be x over 500.
I don't know. P reject. It's just I don't know what it is. That's what I'm trying to find out. Minus 0.5 over 0.5 times 0.5 divided by
500.
500.
Square root.
Okay? All right, now I just need to do a little bit of algebra. Okay? So essentially what I'm doing here, negative 1.645 equals P reject, oh my gosh, minus P over the square root of PQ over M, underline, this case, I'm going to multiply both sides by the denominator, which is the square root of 0.5 times 0.5 divided by 500. Okay, so that will cancel my denominators. On this side, I'm going to get this times that, a little bit of algebra. So negative 0.03 equals P reject minus P. Maybe that's okay. Minus P, that's okay. Good enough for what I'm doing. It's not a registered trademark, though. Okay, so I'm going to, my P is actually, in this case, is 0.5. So I'm going to add 0.5 to both sides. 0.5. And that's going to give me, what happened? That's going to give my P reject. Okay? Okay, so this value here is now 0.46322. Okay. All right, so I found that area. I forgot to give you guys some information. So going back to here, what I wanted to do is I wanted to find the probability of a type 2 error given that P equals 0.48. Okay? Now, as you'll remember here, when we're doing our alternative hypothesis, we always keep the alternative hypothesis vague. We just say it's less than. Okay? In order to find the probability of a type 2 error, you need to have a specific value. Okay? So I'm going to say, well, what if the null hypothesis was wrong? In fact, it was not 0.5, but it was really 0.48. Okay? The null hypothesis was wrong. Okay, so what I'm going to do is I'm going to use this value here, which is 0.48. Okay, I'm going to draw a new normal curve here. Okay? Now, in this case, the mean of my new normal curve is 0.48. I'm going to extend this line up. This is my rejection region up to here. Okay? Now, I want to find this area, the green area. Does that make sense? Okay? So this is my type 2 error. Okay? Now, how do I find the probability of a type 2 error?
Find the value.
I'm going to find my z-score again. I'm going to use this same equation, but I'm going to use different values this time, right? Okay, so my z is still going to equal p hat, or p reject, whatever it is. Okay? What value do I put here? 0.46322 minus p, which is 0.48. I'm going to divide that by square root of 0.48 times 0.52 divided by 500. Okay? All right. So I'm going to do that over here. I'm going to try to make all my fonts green. Okay? So I need my z equals in this case p reject, which is, I just figured out over here, 0.46322 minus 0.48. I'm going to divide that by the square root of 0.48 times 0.52 divided by 500. Okay, I'm going to divide those numbers. I'm going to get this divided by that. What is that? It's the z-score. Okay. Now, given that that's my z-score, so my z-score in this case equals, sorry, let's use the green one, color consistent here, equals negative 0.75117. Okay? Now what do I do with that z-score? Okay, I'm going to plug it in with norm's dist. Right now, is norm's dist going to give me the green area or the white area?
The white.
And I want the green area. How do I get the green area? So it's going to be 1 minus. So my p-value in this case is going to be 1 minus norm S disk of that. Does that make sense? Okay. So that means this is the probability of a type 2 error. Okay? So the probability of a type 2 error is pretty high, isn't it? Okay?
So
Yes.
that 1 minus norm S disk, that's our white area.
That's the green area.
Oh, that's the green area, okay. And that's our probability of making a type 2 error.
Probability of making a type 2 error. And by the way, just as a reminder, we use the letter beta for the probability of a type 2 error. Remember that? Okay. Now, I want to introduce, we talked about power. I thought I did, but I guess I did not. So power, okay, is a new concept, is 1 minus your beta. Okay? So if my so if my probability of a type 2 error is 0.77, my power equals 1 minus that number there. Okay, so my power is 0.226 in this case. Okay? So I don't have very good power. Now, the idea here is, well, let's back up just a second here. Okay? So in this case, my true population was in between my rejection and what I thought my population was. Okay? I've got a pretty high probability of making a type 2 error. Now, if I want to make my type 2 error smaller, I can move my type 1 error bigger, right? Okay, so I'm going to sacrifice, so my alpha is going to have to increase in order for my beta to decrease. And vice versa, if I want to make my alpha smaller, what happens to my beta? It gets bigger, okay? Now, ideally, we would have two distributions that don't overlap, okay? This is the ideal situation. This would have high power, okay? And your probability, so your beta, so your power in this case might be 0.99, okay? If you have high power and a small alpha, that means you could actually use the A word, okay? You could accept. But in this case, I've got a really high probability of making a type 2 error. That's why we reject or we do not reject. Okay, it's the safer thing to do. But given that you have high power and low alpha, you could use the A word in that case. Okay? It's also why I tell you to avoid that. Okay? Let's see, let's bring up some notes here. We're going to write this notes. The further H1 is from our population mean, the smaller your chance of a type 2 error. And also, as your sample size increases, the probability of a type 2 error decreases. Okay? And the reason why that is, I mean, just look and see what happens to your n. What happens to your n in this case? Well, instead of what happens to your n. If you increase your n, what happens to your standard deviation? It gets much smaller, okay? So essentially what we've done is we've shrunk down the variation. If my n was a lot bigger than 500, I could probably get two curves that did not overlap at all. And in this case, I would have high power, and my probability of type 1 and type 2 errors will both decrease. Does that make sense? Okay. Finally, let me erase this. The higher the power of the test, the more likely the test will reject the null when the alternative is true. Okay? So that's why we like to have high power. High power means small beta, small type 2 error. And if we combine that with a small type 1 error, then you can start using that A word. Okay? Now, having said that, do you guys feel comfortable, I don't really have time to do another problem, picking the right equation here when you're finding your rejection region? Okay. Tim?
Does it still just depend on what letters or symbols the known alternate use?
It totally does.
Okay.
Okay?
I'll probably still screw it up, but.
You won't be the only one. Okay? So just think about how do you decide whether it's a Z, whether it's a T, what are the assumptions knowing? And then you can pick this equation, and then you're just going to reuse it a couple of times. Okay? And draw a picture, because this is going to be almost impossible to draw without a picture. Okay? All right, see you all tomorrow. 10.6 is the quiz.